Student pulls a wooden block of certain mass on this rough surface, and you can see these are the forces. This must be an applied force, and it is a normal force. This is a weight, and that must be the frictional force because it is tracked on the rough horizontal surface. They also mentions that it is moving with constant speed. All right, so which means that there's a no change in magnitude of the velocity. All right, it means that this is not accelerating, which means that the sum of all forces, the resultant force must be zero. And when we say that the sum of all forces is zero, it means that not only the forces along x-axis is zero, means that the forces along x-axis or horizontal forces are balanced, but also forces along vertical axis is also balanced. So basically we are going to use these two important aspects of this Newton first law in our calculation, and in this question you have to compare the forces with each other. So we see that this force, the applied force, is applied on this wooden block at an angle theta. All right. So if we make its free body diagram, then, so students, this is the wooden block, and what we see that the one force is applied at an angle theta. So let's say this is a force that is applied at an angle theta. That is the normal force. Okay. This is the weight, and this is a frictional force. If these are, like, because I'm assuming by looking these letters, okay, although like these are the four forces. Now we, in the next diagram, we will make its components of the force, this letter P. Okay students, so this is an angle theta. All right, and you see that this must be P cos theta. All right, and the vertical component, that's why I'm erasing it, okay, because now I have resolved it into its components, so that must be P sine theta. Now if I see that, because in the start I said there is a no acceleration, okay, it means that sum of all forces along y-axis is balanced, or are balanced in fact, and this is a normal force. That's why I should draw the longer vector of w, because it doesn't seem balanced. Okay, so now it seems balanced. Okay, right. So what are the two equations that we get? Let's check. Sum of all forces along x-axis is 0, means that the letter P cos theta, okay, this is equals to the force F, whereas upward forces P sine theta plus normal force is equals to W. All right, now we see that if I take the cos theta on the other side, so F over cos theta, and dear students, you know that the cos theta, if it is dividing, because cos theta will be always less than 1. All right, because this angle theta is not 0. For any of angle, it is always less than 1, which clearly means that this letter P, this force will be more than the force F. Okay, because denominator is smaller than 1, so it will make it larger. And what about N? It is equals to W minus P sine theta. So we see that this is a force that is subtracted from W, which makes the normal force, if it is normal force, less than W. All right. So these are the two things that we should select in this question. So that should be option A.